This is Algebra 2, reviewing for the second semester final, Unit 9, polynomial functions. If we are given the following functions, or given the following function, how many total solutions must it have? In order to determine this, we just need to look at the highest exponent. So if we are given the function g of x is equal to x to the third minus 3x squared minus 4x plus 12, our highest exponent here, so it must have 3 solutions. Adding on to that problem, what are the possible positive, negative, and imaginary solutions? For this, we have to look at Descartes' law of signs. So we look at how many times the sign change in our normal function. So we go from a positive to a negative number, so there it changes 1 time. Stays the same. Negative to a positive, there it changes another time, so we have a grand total of 2 changes. So we have 2 or 0 positive answers to this. Okay, now to look at our negative solutions. Our negative solutions, we want to view what g of negative x would be. So essentially that ends up changing the sign of all of our odd exponents. So the x to the third would become a negative value. Minus 3x squared would stay minus. Minus 4x would change to plus 4x and then plus 12. Here we just have one sign change, so we would have one possible negative solution. And then we know that we need a total of 3 solutions. So if we have 2 positives and 1 negative solution, that means we have 0 imaginary. However, we could have 0 positive solutions and 1 negative, which would leave us with 2 imaginary. So those are our possible solutions that we could have. Still using that same exact function, we are now going to state the possible solutions. So all of our possible solutions are all the factors of our last number divided by all the factors of our first number. This time our first number is 1, so we just have to list all the factors of our last number. So the factors of 12, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. And now we are actually going to find the solutions. So if we refer back to what we found out, that there are 2 or 0 positive and 1 negative, and then 2 or 0 imaginary, we're going to focus on finding that 1 negative solution first because we know for sure that there is a negative solution. So to do this, we're going to set up synthetic division. So 1, negative 3, negative 4, positive 12. And we're going to start searching for our 1 negative solution. You can start at whatever value you would like to. Here I'm going to start at negative 2. So negative 2, we drop down the 1. 1 times negative 2 is negative 2, plus negative 3 is negative 5. Negative 5 times negative 2 is positive 10, minus 4 is 6. 6 times negative 2 is a negative 12, plus 12 is 0. I lucked out. I found the right solution the first time. So one of our answers we know is negative 2. Now I'm going to look at my reduced polynomial that we just found, which is x squared minus 5x plus 6. And from here, I'm going to solve that. You can solve this by doing the quadratic formula. You can factor it if it's possible, or you could complete the square. Here, I see this and I notice that this we can factor very easily. So I'm going to factor it. My first terms are x and x. Multiply to get 6, add to give negative 5 is negative 2 and negative 3. Make these both equal to 0. So if x minus 2 is 0, our x value is 2. If x minus 3 is 0, our x value is positive 3. So our solutions then are negative 2, positive 2, and positive 3.